Okay, so let's talk about some financial models, all right? One of these, maybe two of these you've seen before, and maybe you haven't. So the simple interest one, I'm pretty sure you've seen before. Quite a while ago, but I believe you've seen it. I equals P times R times T, okay? Compound interest, a very different formula. Continuous compounding, still a very different formula. Now, in all of these particular formulas, the finance world will calculate how much interest they owe you when you leave your money in a savings account with them. Conversely speaking, they also use these formulas to figure out how much interest you own on a loan. So say you get a car loan, they're using one of these formulas to figure out how much money you owe them for borrowing their money. So anyway, let's go back. Do you notice in all three of these formulas there's the variable P? Well, P stands for the principal. Another word for principal is the initial deposit. And by the same token, instead of initial deposit, it could be the initial loan amount. So be aware of that. So P stands for principal, or the initial deposit, or the initial loan amount. Okay. Also in all three of these formulas is the variable R. R stands for the interest rate. Now, this is a percentage. Okay? You ever heard of APR, annual percentage rate? Okay. By the way, the principal is money, so I'll put a little dollar sign there so we have that. The other variable that's in common with all three of these is the T. T stands for time. And in the finance world, time is always in years. Always. As I mentioned, APR, annual percentage rate. They want you leaving your money with them as long as possible in that savings account or that CD or whatever. Why? Because they're using your money to make money and they give you this much back on their interest. Gotcha? Okay. Now you're like, what happens if it says 6 months? Well, 6 months is how much of a year? 0.5. So you'd have to put 0.5 for the time. Right? Okay. If they said 9 months, that's 9 out of 12. And that reduces to 3/4 of a year. So understand that. If they give you months, you're going to have to convert it to years. Cool? Okay. Now, this particular formula has the variable I, which none of the other ones do. I stands for the interest earned. How much money did you earn at the end of the month when you left, I don't know, however much money in the savings account? Good? Okay. These two formulas still have some extra variables. They both have an A. A represents the ending balance in the account. Literally the ending balance in the account. That's your money that was in the account plus the interest that they deposited into the account at the end of the month. So A is the ending balance in the account. Got it? Okay. This one still has one more variable that the other two did not have. This one has an extra variable, N. Now, you're like, well, what does N stand for? And I'm going to write N down here because I have more room. N, number of times per year the account is being compounded. So N is the number of times per year the account is being compounded. Like, give me an example. If they say the account is being compounded monthly, how many times a year is that? Good, 12. If they say the account is being compounded daily, how many times a year is that? Good, 365. If they say the account is being compounded quarterly, how many times per year is that? Good, 4 times a year, because there's 4 quarters in a year. Got it? Okay, so depending on how they phrase the problem, tells us which formula to use. If they say compounded quarterly, I'm going to use this compound formula. If they say it's compounded continuously, I'm going to use this one. If they say, hey, the simple interest, then I'm going to use this one. Cool? If they say compounded continuously, I'm always going to this one here where it says compound continuous or continuous compounding. If they say compounded daily or quarterly or monthly or yearly, I'm going with this one right here of just compound interest. Cool? Okay, so hang in there. Got some examples. Okay, so let's have some fun. Suppose that you inherited $10,000 and you were debating to invest it in two different accounts. You are looking at one account that pays 5% interest. It's compounded quarterly. And you're planning on leaving it in there for 4 years. Okay? You're looking at a second account. And the second account is paying 4% interest, and it's compounded continuously, and you're still going to leave it in there for 4 years. So you're like, well, which account would pay me more by the end of the 4 years? So here's the thing. We have two problems to work out because you want to figure out where you're going to put that $10,000 to earn the most amount of money. So let's look at this one over here. It's being compounded quarterly, isn't it? Okay, so since it's quarterly, compounded quarterly, what formula are we going to use? That's right, the compound interest formula, which is A equals, right? So let's take a look at this one. Our P is the 10,000, correct? Because that's principal. 1 plus R stands for the rate. That's 0.05. N is the number of times per year the account is being compounded. So in this case, it's being compounded, that's right, quarterly, which is how many times a year? Good, 4. Raised to the N, which we just said was 4, times multiplied by the time, which is 4 years. Gratefully, it's in years. Remember, this is always in years. These finance models are always in years. Okay, and then we get to plug it into the calculator, don't we? Okay, so you plug it into your calculator. I'm going to plug it into my calculator, and we're going to see what we get here. How are we doing? You guys okay? Let's see. Now, do I really need to tell you how many decimal places to round? I hope not, because we're talking about money, right? So, I ended up with $12,198.90. Hopefully you have the same thing I do. And you know, it's always a good idea just to do a quick double check to make sure that we have the correct answer. Does that make sense? And when I did my double check, I ended up with the exact same answer. Good. Okay, and now we have this other account, and it's compounded continuously. Is that the same formula? You're right, it's not. That formula looks like this. So I'm looking for the ending balance. My principal is $10,000. Remember, E is just E. The rate, that's right, it's 4%. And the time, gratefully it's in years, is 4. So, you got your calculator, I got my calculator. Let's see what we get. Okay, so I have an answer. Hopefully you agree with it. And again, I shouldn't have to tell you how many places to round, should I? I have $11,735.11. And I'm going to do one quick double check because it's always good to double check your answers just in case we made a simple error punching, right? And I ended up with the exact same answer. Good. So, where are you going to invest that $10,000? Knowing you're going to leave it there for 4 years, where are you going to invest it? Are you going to invest it in the account paying 5% quarterly or into the account paying 4% compounded continuously? Right. We're going to invest it in here in this particular account because this account is paying me more money. Good? So, a real life problem, isn't it? So when you get some extra money and you're like, I'm just going to put it away, I'm going to save it for when I graduate college, or I'm going to be saving up for a car or whatever, you get to figure out which account would be better. Remember what I mentioned, these formulas also work for loans, don't they? Hang in there, I'll be right back. Okay, so let's have some more fun. So let's say you just graduated with your bachelor's degree. You finished at Southwestern College or whatever college you're going to. You went on to your 4-year college. You graduated with your bachelor's degree. You got this great paying job and you're telling yourself, you know, I've been nursing and milking this old clunker of a car for like 4 years now. And now it's time to treat myself to a brand new car. And I got this great paying job. So you decide you're going to treat yourself to a brand new Tesla. Not bad, right? You're like, hey, I'll be efficient with the energy, it's electric, yada, yada. And that car turns out to be a $60,000 car. And you're going to decide to finance it. So the salesman goes, we can finance you, no problem. We can finance you at a rate of 3%. And you're like, 3%, super. And then they run your credit history and they realize you don't have a lot of credit. So forget 3%, they're going to finance you at 6.5%. And you're going to take out an 84-month loan. I'll spread the payments out. So you're going to take out a 7-year loan, right? Because that's for 84 months. And this loan is going to be compounded monthly. And so now the question I have for you is this. At the end of the 7 years, did you only pay $60,000 for the car? How much did you really pay for that car at the end of the 7 years? So, let's take a look. This says compounded monthly. Agreed? So, what formula are we using? That's right, we're using the compounding formula, right? The compound interest formula. And I want to know how much we're paying at the end of the 7 years. My principal is $60,000. My rate was what? That's right, 6.5%. Oh dear. N is compounded monthly. That's good, 12. And 12 times 7 years, right? So let's see how much you end up paying for this car at the end of that 7-year period. You get your calculator, I'll get mine. I know some of you are faster on the finger punching than I am, and that's okay. Be my guest. So, I got my answer. Do you have yours? Now remember, by the way, I put the wave in because it's approximately because I have to round, right? So it's not like exact, but this is close enough. So I ended up with this car at the end of 7 years costing you $94,454.36. That's a lot of money. That's $34,000 more than what the price of the car was, right? That's like half another car. $34,000 is just a little over half another car, right? Yeah. So when you decide to buy a vehicle, brand new vehicle, used vehicle, and you're going to finance it, it's not a bad idea to do your own computations before you sign on that dotted line to see if you really want to spend that amount of money. And if you're like, well, I need to get the loan, then consider paying extra principal or extra on the principal so you pay it off faster. Hang in there. I got another problem for us. Okay, so let's talk about that car again. Maybe we should save up for that car instead, right? Okay, so let's say you've been working very hard through your college career and you've put money aside and you even got some money for Christmas and birthdays, and maybe you got a little bit of inheritance, and somewhere along the way you've been able to save about $25,000. You're like, that's a lot of money. Sure can be. And you want to know how long it's going to take to double this amount of money. So you're looking to double this amount of money. So you're going to put it into an account that's compounded continuously at 5%. With me? So my question to you is this. How long is it going to take? How much time is it going to take for this $25,000 to double if you put it into an account paying 5% compounded continuously? So we have a formula, don't we? Because it's compounded continuously, isn't it? And so your formula is, right? And you're looking for time, aren't you? Okay, so T has to be my only variable here. Well, I know the principal is $25,000, don't I? I know the rate is 5%. I'm looking for how long it's going to take. Well, that means I must know A. I must already know the ending balance, because the only variable that can be in this formula is T. Yes. It said double. So if it's doubling, how much am I going to have at the end? I'm going to have $50,000. You with me? Whoops, one more zero. Okay, time to go solving. Do you agree? All right, so first things first, what are we going to do? Correct. Divide both sides by your $25,000. Which leaves you 2 equaling e to the 0.05t, doesn't it? Okay, and now I need to get rid of that base e, don't I? I need to get rid of that exponential so I can get the t on the ground. That's right, you're going to have to take the log base e of both sides. And log base e is the same as, excellent, ln. So I have the ln of 2 equaling e to the point, whoops, our e's canceled, didn't they? See, this is why I need you guys working the problem with me. Equaling 0.05t, which means to get the time, I'm going to have to take the natural log of 2 and divide it by 0.05. So, you get your calculator, I'll get mine. What'd you get? Yeah, I got that too. I'm just going to do a quick double check just to make sure I did it right. I sure did. How long did you get? Yeah. This is going to take approximately 14 years for this $25,000 to double. Well, I guess instead of buying a car, maybe you're saving up for a down payment on a house instead, right? Here's the deal. All those finance formulas that we went over, they're all real life problems. And I've given you 3 real life problems. If you have money and you're going to invest it, you can figure out which account is best to invest it into. If you're going to buy a car or even a house or anything on credit, you can figure out how much they're going to charge you at the end of that time period, right? If you're putting money away and you're trying to figure out how long it's going to double or even triple or quadruple, you know how to figure it out. These are all real life problems that you can keep right here in your memory. You can keep it right here in your tool belt, so to speak, you know, with your calculator handy going, is this a good deal? Is there something better? Cool? Okay, so you have fun with this stuff, and I'll catch you on the